Let's start with today's lecture. So first we'll talk about transport services and protocols. What services are being provided by the transport layer and the protocols that we'll be covering at this layer. So transport layer provides us logical communication, right? Uh, Between application processes means there may be an application process running on this machine here, and the other application process is running maybe on the other machine on the other side of the planet, right? So the job of the transport layer protocol is to provide logical end-to-end communication. By saying logical end-to-end communication, we mean that transport layer is really not concerned about the many different routers or data link layer protocols or links in between source and the destination machine. So irrespective of different links in between the host and the destination machine, the transport layer provides us process-to-process communication. And we'll try to elaborate this with the help of a scenario in a minute. So at the end, when an application has to transfer something to the other end, so whatever is coming from the application layer is encapsulated into a segment at the transport layer. At the receiver side, these segments are assembled, combined, and the data is forwarded to the application at the application layer on the destination. So the protocols that we'll be covering here, these are two basically: transmission control protocol and user data graph protocol. TCP is connection oriented, whereas UDP is connection less. So let's try to elaborate these points with the help of a scenario. Okay, so let's assume that we want to make communication possible between two machines. So we have machine A and machine B here. There is a core network between the two machines. Here we have multiple routers, for example. So this machine A is connected to, say, router R1. I'll label it in a minute. And say this router is connected to R2, and R2 is connected to, say, R3. And there is another direct connection between R1 and R2. And this router is connected with the other machine. So here we are saying that this is machine A connected with machine B with the help of this core network, where we have router R1, which is connected to router R2, and there is another connectivity from R2 to R3, and R1 is also directly connected with R3. And in this scenario, we can have we can have a complex scenario where there are many routers are involved in order to reach from A to B. So there are different types of connectivity here that we need to identify. So one connectivity is that this machine A is connected to R1. So this is one type of connectivity where A is connected to R1. So see, A is one node and R1 is another node. So we can call it, this is, we can call it node-to-node connectivity. Right? So where one node is connected to another node, right? It means A is one node, R1 is another node, so A is connected with R1. Similarly, this is also node-to-node connectivity, right? Where R1 is connected, with R3, and obviously the link between R1 and R2 is also node-to-node connectivity, and similarly the link connecting R2 and R3 is also node-to-node connectivity. And also on the other side, this router R3 is connected with the destination machine, say B, and this is connectivity between R3, router 3, and B is also node-to-node connectivity. So, so this is the general symbol that we use, or notation that we use for router. Okay, so this is one type of connectivity here. By the way, this type of connectivity is the responsibility of data link layer. So data link layer is responsible for providing node-to-node connectivity, right? So in order to reach from machine A to router R1, we need to have the physical address or the MAC address of this router R1, or this port of router R1. So if I want to connect these two machines together, so yes, I need to have the MAC address, okay? Right, but there's another type of connectivity here. And this connectivity is between machine A and machine B, where machine A is connected with machine B, right? And this type of connectivity is called end-to-end. End-to-end connectivity. So you can clearly see A is one end in this scenario, A is one end and B is the other end that we want to connect to, right? So the connectivity between the two ends is known as end-to-end connectivity. And this is the responsibility of network layer. So in our reference model, OSI or TCP IP model, this is the responsibility of the network layer. So if I want to reach from machine A to machine B, so you can see there are many different routers involved in between. So I need to make a routing decision here. So for example, at R1, from reaching machine A to R1, I need to make a decision. Either the data will be forwarded to machine B through R2, or data will be forwarded to machine B through R3. So here we have to make a routing decision, and you can see in a real-time scenario, it's a complex problem where we have many different routers involved in between. So here we have to make a routing decision. So MAC address is not enough for me here. So if I want to reach to machine B, obviously I need to have another address. And this time I need IP address for this purpose. Why? Because IP address is hierarchical and means we can make routing decision based on the information in the IP address, right? So this means if I want to reach from machine A to B, there are many different types of links involved in between. So this link can be, for example, wireless. At the moment, it's wired link, and this link can be based on Ethernet if it is not wireless, or maybe it's based on Wi-Fi, right? So there are a variety of links, there are a variety of routers, there are many links in between, right? So I can reach to other machine using what? Using IP address. But reaching to other machine is not enough. Why? Because um, because at any machine in the network, there are different processes going on. For example, at machine A, I'm having HTTP protocol. There's a process representing HTTP protocol. Maybe I'm having SMTP protocol, or I'm transferring a file. For that, I have FTP protocol. And similarly, on machine B, there are different processes going on. Right? For example, FTP, and then we have maybe SMTP. Remember, all these protocols and applications we have covered at the application layer, or HTTP. So reaching at machine B is not enough. So we also need to identify which process of machine A will be communicating to which process of machine B, right? So for example, if I want to complete this end-to-end communication cycle, so I need to identify, for example, I'm just assuming that HTTP process of machine A will be communicating to the HTTP process of machine B. So there is another type of connectivity here, right? So what do you think, what type of connectivity this is? This is, yes, you're right. This is process to process communication or connectivity. And what do you think, which layer is responsible for this process to process communication? Yes. Transport layer is responsible to provide us this process to process communication. So see, if we were trying to reach from machine A to this port of router R1, so we need to have the MAC addresses, right? And if I want to reach from machine A to machine B, and there we have to make routing decisions in between. For that, I need to have the IP address. So what about providing this process to process communication? What do you think? Do we need to have uh, any process ID or address? Yes, we do, right? So if I want to identify um, the process of machine A, which process of machine A will be communicating to which process of machine B, I need to identify these processes. And I can do this with the help of process IDs, which are called port numbers. Right? For example, for HTTP, we have port 80. For SMTP, we have port 25. For FTP, we have port 21, right? So these are port numbers that we have to use in order to tell machine B that it has to forward this data that is coming from machine A to port 80, which is representing HTTP process. Okay, so when we say the transport layer provides us process to process logical communication, this means number one, it enables process to process communication, because without it we won't be able to complete this communication process, number one. Number two, here the transport layer is not bothered about the links in between A and B in this scenario, and the types of link and the technology that is being used at the data link layer. So irrespective of the technologies and the links and the number of links, transport layers provides us process to process communication. Now, if we have to um, forward data using, for example, HTTP from machine A to machine B. So whatever we are sending, um, whatever is being sent by the application layer will be encapsulated inside a segment at the transport layer. So let's try to understand this concept. So remember the layered model that we covered earlier. So there we have different layers. For example, we have physical layer, then we have data link layer, then we have network layer, and on top we have transport, and at the top, by combining the upper three layer, we can have the application layer, right? So this is a hybrid model that we have discussed earlier. So whenever any application transfer data from machine A to machine B, the data is first forwarded from application layer to transport layer. So whatever we want to transmit will be encapsulated inside a protocol data unit, which is called a segment. Basically, it has two, broadly speaking, two parts. One is header, and the other is the data or the payload field. So this is called segment. For TCP, we call it generally the notation is to call it TCP segment. For UDP, we call it UDP datagram, but datagram is also used for the protocol data unit at the network layer. So for simplicity, we'll call it either this is a TCP segment or a UDP segment, because there are two types of protocol at the transport layer that will be covering, either TCP or UDP. Okay. So as the data is transferred from transport layer to network layer, this TCP or UDP segment is encapsulated inside a datagram. Okay. So broadly speaking, datagram has also two parts, header and the payload field. So this means this TCP or UDP segment will be encapsulated inside the payload field of the datagram. By the way, in the TCP or the UDP datagram header, there are many different fields, but two fields are important here to identify. Can you guess? Yes, right. So there are two fields identifying the port number of the sending process and the port number of the receiving process. Similarly, in the datagram's header field, there are many different fields, but two fields are very important. Can you identify with this, with the relevance of this scenario? Yes. One field is the IP address of the sending machine, and the other field is the IP address of the destination machine. Okay, as the data is moved from network layer to data link layer, so this datagram, which is encapsulating TCP or UDP segment itself, is encapsulated inside a frame, right? So this we call it at the data link layer, it's a frame. Okay, so frame also has, broadly speaking, two parts, header and the payload field. The data of the payload field will be encapsulating the datagram coming from the network layer. And also, again, if we look at the header field, it has many different fields, but two fields are important considering the scenario. Yes, you're right. One field is the MAC address of the sender in this scenario, and the other field is MAC address of this port of router R1. By the way, if I make a decision to send data from R1 to R2 to follow this path, for example, what will be the source MAC address and what will be the destination MAC address when the data is forwarded from R1 to R3? So we'll be having your answers in our live session. So are we clear about the datagram or the encapsulation process? This whole process is known as encapsulation process. And similarly, on the destination side, we have this decapsulation process where the receiver will first receive a frame, then the receiver will decapsulate datagram, and then it will decapsulate, extract segment out of it. And by just looking at the header of the segment, the data will be forwarded to the respective process at the destination machine. Okay, so I hope we are clear about the logical communication property of the service of TCP, what we really mean by saying logical communication. And now we also know that whatever is being forwarded by the application layer will be encapsulated inside a protocol data unit, which is called a segment. And we can have more than one segments to accommodate the data that is coming from the application at the application layer. And at the receiver side, will be assembling, combining the data from these segments and will forward it to the application layer. Okay,